with Mike Nadata. Mike Nadata is the owner and lead practitioner at NY Rehab in New York. Mike has been working closely with me for over a year, exploring and developing 3D printed sockets and socket workflows for him and his team. Starting off with a journey in 2014, Mike has been exploring not only building his own printers, but MJF prints and outsourcing printing, and looking for different ways to design software and new ways of creating sockets for a long time. And after he and I started working together, we got to work pioneering a brand new way of creating BK sockets. And these designs and everything that we're going to disclose to you today is a part of our journey as it stands now. It's still ongoing. It's still going to change. But the important thing is the workflows that we pioneer work. The viable products that come from it are on patients today. The ground floor that we establish for you and the field at large is meant to be shared and distributed. We want you to be a part of the journey and see these designs for yourself, to feel them, to hold them, to design them yourself and print them yourselves. And we're going to talk about everything that went into our journey and how you can make these sockets yourself. What kind of design features, what kind of componentry you're looking for, what printers to use, and the different materials that we explored and the results from stress testing. So really excited to share this with you guys. This is going to be a great interview. And now here I give you Mike Nadata.
Cool. So what are we doing today different from last time?
I think it's kind of similar to last time, just as another take, an introduction to the course. And it's going to be talking about, NY Rehab, process prototyping, and then, making the 3D journey with Mike Nadata, or how digital workflows change the technician's role with Mark Rico.
We have 11 beasts out to date.
That is so amazing, and we're still. I think we should stick with the beast, huh? That's going to be the official
You know
name?
what? It just flows. I don't know. You gotta. It just comes out. It's a beast.
Yeah.
A beast. And I've been cataloging like weights, patient weights. You want to hear real quick what I have going on?
Okay, sure. Let's hear it.
Yeah. So I have a bilateral BK. She's 104 pounds. Okay.
Okay.
Good to go. I have a guy who's 160. The rest are unilaterals. 162 pounds, 186 pounds, 140 pounds, 185 pounds, 150, 210 pounds, 230 pounds, 256 pounds,
Wow.
168 pounds. Tomorrow, I'm going to be very cautious of this one. We did a Beast XL on him, 270 pounds.
Oh my goodness. Okay. Wow.
So we're that's the one I'm going to reserve the right to, just if I don't sleep well, just make that into a fitting.
Yeah.
But easily, 250 pounds. I think I wouldn't bat an eyelash right now.
That's fantastic. So
yeah,
that's so exciting. So let's dive in then. So let's start off with just the product. So the Beast, we've been precluding about it. We got to go over some of the cool things that the Beast can do. So I'll superimpose some images, but what are some of the design features that we've done with this socket that you really appreciated, that came to be the successful factor? How much does the lattice work, if at all? Does that actually bring about the change we're looking for?
I think so. I think, again, our journey in 3D printing, my journey in 3D printing since 2014 has been to print something that is at least as strong as a copolymer vacuum formed socket.
Mm-hmm.
Again, a copolymer vacuum formed socket does not break, it does not shatter, it does not tear. It has some elasticity to it, right? So it has a yielding to it, but it does not explode. Something that even carbon fiber doesn't necessarily possess. So I always felt, if I can vacuum form a socket, it should be at least as strong as that. And the issue had been that when we were first doing polypro and copolymer 3D printing, using pellets in the beginning,
mm-hmm.
There was a delamination along the z-axis. We would have that issue, and that was really our journey, the journey of the z-axis.
That's pretty crazy. Like the fact that you designed your own machines and they were pellet printers back. When was that? It was 2014, you said?
2014 is when we started. I think they were operational by 2016. Was
Yeah.
that 2014? I was still in the research and development stage. FDM printing isn't necessarily strong enough, for at least at the time. So then I felt that maybe pellet printing would give it the strength it needed. And the best we got with our machines wasn't that we had the Z layer, is that it would still crack. Again, our mode of testing isn't, I wouldn't call it an ISO standard necessarily. I don't have the hydraulics. I don't have the machines. We would bolt our sockets into a vise, and we would take like a crescent wrench or pliers and just start tearing at it,
Yeah.
tearing at the proximal walls, just to see if there was, if it would maintain its integrity. And like I said, the best we got was that we would have a Z layer adhesion, but it would fracture across the Z, across the plane, across the Y axis, I guess.
Wow.
So that was great as in terms of a 3D printing achievement, but it still didn't give us the quality that we needed. You could do that with a polypropylene socket. You could do that with the carbon socket. Eventually, you take a crescent wrench. You take a wrench, and you will break it at certain levels, but it won't be straight. It'll be yielding. It'll have some give to it. Again, I used to give the example of a run flat tire, right? The idea is that, the run flats would get you to safety. So you could be walking, you could be driving down the road, and you drive over a 30 nails. You don't fly into the wall. You pull over. It gives you that time to drive the extra 5 miles to safety.
Yeah.
And I always felt that a prosthesis, even carbon, even whatever, if there's a failure of the device, the guy got hit by a car, the guy walked the wrong way, ran the wrong way, twisted it the wrong way. Even if it fails, it shouldn't be a catastrophic failure.
Yeah.
It should support the person enough so they realize something is wrong. I need to sit down and I need to have this service. That was always the minimum that I was trying to achieve. And when something would just, shatter, that wasn't a minimum. That was just
Yeah.
not good.
And shattering is definitely the word on this block when it comes to MJF printing. Based on our results, can we talk a bit more about that? Because it was in December we decided to do a run, and it was really eye opening what was happening with what these were supposed to be superior prints, and everyone was recommending an MJF print, and it turns out there's a lot of flaws to that.
Yeah, I mean that was shocking because at one point, again, it's a journey of personal growth I found with this printing, and I was so invested in the FDM. Like I said, we spent years. I had engineers. We partnered with some very experienced MJF printing companies who work directly with HP, and we made gorgeous devices, and they looked great. They felt great, but as a lark, because we had heard something. Maybe one of our wall thicknesses may have been off, and we must have done like 10 or 15 of them, right?
Mm-hmm.
And we thought one of them may have had an issue. So as a lark, I didn't even think to try to test it, and I put it in the same vise I've been doing for years, and with very little force, I not only was able to break that which that proximal wall that I did so many times, so many hundreds of times over the years, but besides that localized failure, the entire device just shattered, almost like like a fault line, like for an earthquake.
Yeah.
It just spidered, and that was probably one of the most catastrophic. Something that I've seen on polypropylene sockets, that a polypropylene socket could shatter like that, and that was it. We pulled the plug on all of that. So that kind of just said to me, just because everyone says you get what you pay for, not necessarily so. I mean, this is a case that it's just and I had spoken to people at HP directly, and I had spoken to their testing, and it was not anything that made me sleep better at night. They claim that they've compared it to carbon sockets, and again, everyone's carbon socket could be laid up differently, and there's different reinforcements, and there's different stress testing. I wasn't satisfied that, even though they were telling me that the stresses I was putting on were not real stresses, nobody would put so much stress on a socket like that.
Mm-hmm.
That's what they're saying. At the end of the day, I always felt that It wasn't going to be from repetitive walking that somebody's going to, break a prosthesis. I say it's not going to be the 300-pound, triathlete who's a beast in itself, huh? And is just walking around and running and whatever. It's going to be the 95-year-old lady who's struggling to get out of her wheelchair and just has some type of crazy extension moment and hits the side of the chair, and all of a sudden the thing's going to shatter. It's going to be that which you can't quantify or predict is what's going to break a socket.
So your journey then, just to recap then, so you custom built your own printers, you got into high level printing, you bought into the MJF, and then once all of that failed, we sort of did some soul searching, went through some milling, and then came upon the low end machines, low end FDMs, $400 desktop machines, and and affordable low end materials like just basic TPU, basic PETG. What was the point where we had the eureka moment where those things actually came together and actually worked for the first time? Because it blew my mind that this was out competing anything and everything I've been told up until this point about printing.
So that was just that. It was a fluke. So all this time, again, since 2014, what we didn't get into was, while we weren't necessarily 3D printing definitive sockets, we always had a hybrid method of fabrication. We would 3D print out of TPU inner sockets, and then we would CNC carve outer sockets offset, and then we would laminate that. And I mean, that's really how we do business here. And at one point, when I just got frustrated with the pellet machines were making all of our inner sockets, but they were very finicky because I think we have 4 still. They would just, something would go every week. There was always at least a week where 1 or 2 printers were down, and it was, a thermistor, it was a heating element, it was a rail, and they were built. They're huge. They're
yeah, they were overspec
machines, but at the same time there was just so much going on, and I was just like, I need to just, what's his name? The Lemon Lattice gentleman.
Oh, Derek Schmidt.
So I came across one of his LinkedIn videos where he was talking about the Sidewinder, and he's printing check sockets, and I think he spoke about other things. And I said, maybe we should just, technology. We entered the field in 2014, and by definition, 9 years has passed, right? 8 years has passed. A lot has happened, even in the FDM realm. So I'm like, for $400, $300, I'm going to buy one of these printers, and I'm going to just, follow what's going on. And at that point, we also didn't have any more engineers. Our last engineer had moved to Florida, so we were back to just doing business as usual. And and my lead technician had taken over, the carving and so on and so forth. So he was very interested in learning how to 3D print. We bought the thing, and we started playing with the machine, and we were both amazed. I guess we had a file laying around somewhere. He was able to print a socket, like an inner socket or something out of PLA, whatever it was too easy and too quick, and it looked gorgeous. So, that light bulb went on, and then we met up with you, right? That's really the chronology of it, right? Because you were helping Mark figure out how to do these hybrid things himself, so we could make inners and carve outers. So he was dipping his feet, and then at one point you came up with this lattice design, because that's when we were going into the MJF, and we both agreed that the MJF by themselves still needed a support. So you had showed us this lattice design, which was beautiful, which gave a lot of strength to at least the bottom of the socket, which we always call the kill zone. Always concerned that the socket will rip off of the base. And we had these printers that are printing these TPU inner sockets gorgeously. And one day I asked Mark, he was playing around. We do tooling with it. We print PLA parts sometimes when we laminate or for other things. And he was making a cast or a die of something, and he was supposed to make it out of PLA. And instead he made it out of TPU. He made like a brick. And he accidentally did it. And I hold this thing, and I'm like, this is crazy. You could kill somebody with this. It was so solid And I was like, why can't we make a socket out of that? Why can't we make a definitive socket out of it? Understanding the properties that TPU is generally um, a flexible material, but the more reinforcements, right, and the thicker and so on, because that's what it was. This was a brick. He printed a box by accident, and that's where we dusted off your lattice design, and
Mm-hmm.
the beast was born.
Yeah, and that's the coolest part is that we were able to bring two low cost solutions together with good design to actually make a viable product for the first time, and just no one had really stopped to really consider that. And the power of good design can go a long way. So when it came to designing for low cost machines and managing a fleet of low cost machines, I know there's naysayers out there who talk about running 10 FDM desktop printers is a full time job and something no one would ever want to tinker with and figure out and deal with. They would rather just send it off or have a big expensive machine that does it all in one shot. What has your experience been after sampling and building your own FDM printers and coming back to the solution? How does it scale? How does the workload, on the side and the maintenance that you have to go through, how does that stand up to your standard?
So you had mentioned like even a low cost design. What I'm even pointing at, and I'll answer your question through this, is that I think this is the superior work model, is what I'm trying to get at. Meaning, if I had to choose right now, money was no object, I believe that you're getting a superior product with these Sidewinder fleets or whatever FDM printer fleets. Printing TPU, I think it's superior on every level. I think it's superior to the patient. I think it's superior to the prosthetics manufacturer. And when you're talking about maintenance, these simple, I wish I made money off of these Sidewinders. I wish I had a stake in their company. I don't know them from Adam. I could say this. I don't have any financial whatever. They're very, they're built well. And what's crazy is for $400, $300 a pop, if they last a year, great. And if they don't, we live in a disposable society. You buy a new one. It costs less to replace them than they are to fix. So if you have, 5, 6, 7, 8, 9, 10 of them, if you have 10 of them, you're spending $4,000 a year, right? And that's, you got a mill, you got 10 of these going, right?
Mm-hmm.
You got a farm going here, $4,000 a year. If you bought one higher end FDM printer, that's $4,000. If you're buying, the MJF, that's $4,000 every 2 weeks you're spending, or whatever it is. You can't, financially, it's a no brainer. You could be recycling new machines. Who cares about? There's no maintenance. You just buy a new machine, and that's factored in. So that's number one. Number two, the fact that you have 10, prints going simultaneously. Well, guess what? Nothing is perfect in this world. There will be a time where you have a print that will fail. So instead of it hogging your entire machine, the others will survive. Or you print, where there are times where we'll print the same thing on two different machines because we really need it the next day. And and if you waste the money on two, so you spend $30 extra in filament. It's really, when you talk about the cost of fabricating conventionally, you talk about the cost of all of this. It's a printing on a higher level. You can't even justify what we're doing. It's just blowing it out of the sky, and the quality is great. The devices, again, to my standards, I only hold by me, Michael Nadata, New York Rehab. I can't tell you that I'm certified in anything other than prosthetics and orthotics. They're stronger. They seem to be, you see the videos. I literally drive over these sockets with my 20 million pound SUV, and they bounce back.
Yeah.
Even when you do that with copolymer, they flatten because they're malleable. But these actually bounce back and they retain their shape. Forget about the fact that you take the crescent wrenches and the pliers, and you cannot split these sockets. You just cannot do that.
Mm-hmm.
So you have a superior product. You have the leeway to, so to speak, do better with your patient, because you can just reprint something if after 2 months they shrink and insurance isn't going to pay for another one. You just spit out another socket. It's $30 out of your pocket. You're saving money on your manufacturing. And then I think that the beasts themselves, Besides just being stronger, we've had a lot of very positive clinical um, benefits from as opposed to a traditional socket.
Yeah. Can you talk more about what the patient experience has been, or what are some of the mechanical features that that a TPU socket provides in terms of maybe comfort or malleability that a carbon fiber or polymer
Right.
doesn't offer the patient?
So the one thing I didn't get into is that again, obviously, there's no such thing as the perfect anything, right? So TPU has its flaws just like everything else. Um, in order for the TPU to work, you got to drink the Kool-Aid, and that Kool-Aid is you need to do a vacuum socket because they are heavier than carbon. There's no question they're heavier than carbon. It's heavier than MJF. Um, so you need a vacuum suspension which really connects properly to the patient. They don't feel the weight. Every single piece I've ever put on a patient, even though the socket is heavier, every patient has commented that the socket, they've never worn such a light socket before, such a light prosthesis, and
Mm.
that's really because of the total fit and the vacuum suspension entailed. So Kool-Aid number one, first drink, is that you got to do vacuum. I don't think it would be as welcomed by patients if you had a locking suspension because they are heavy. Again, if you have somebody who's maybe stronger and better fit, but then you have to start questioning, why am I putting it on this patient?
Hmm.
Because as clinicians, we want to save money, we want to manufacture cleaner, easier, better, and that's what the printing does for us. But at the end, it's not really fair to the patients if they're not benefiting from them. So I can honestly say that a vacuum beast benefits my patient. So it has to be vacuum. In particular, we use the VIP made by Alps. They're lightweight, simple pucks that you put in, and it achieves perfect vacuum. Our sockets are airtight. They're easy to maintain, and I find that it maintains vacuum longer than a traditional socket because the edges are much softer than a carbon socket, so the sleeves aren't tearing. It's not as fragile. The socket, the print is inherently airtight.
Hmm. And you
So
had to experiment with that, right, to get an airtight
I
FDM print that
experiment
is
with
not easy
setting
to do.
to print, but now we print in every single one. You as long as you follow the recipe, they're in. Um, the last thing I like about it, and again, this is just completely serendipitous, is that because there is some flexibility to the top, it's not very flexible, but there is some give around the edges. The patients find that it's more comfortable because they
Hmm.
don't have that harsh edge. Um, Hitting them, they feel that sitting comfort is better. Again, this is anecdotal, but we're still using very similar trim lines to what we were always making with carbon sockets. But people are telling us the way we're making our beasts with these VIP vacuums are that they're actually lighter to sockets that I can actually weigh and tell you they are not, but they just feel lighter and they're more comfortable. And so that I could say is that I'm not only am I winning, so to speak, in the costs of these devices, in the speed that we're producing them, in the precision that we're offering, but the patient is getting a much better experience as a result also. So
Hmm.
they're checking everybody's box.
That's fantastic. And
Yeah.
you get to own your own design pipeline, right? Now that you have sort of, so Mark Rico, your lead technician, he's almost fully trained. He's taking my workflows and he's improving them and making them your own, which is really exciting to see. You have firsthand experience of what it's like to hire a highly sought after professional like an engineer and then having them build a custom machine and then having them leave, as opposed to having a workflow and a curriculum and a system of machines that scales, right? Can you talk briefly about sort of that experience and the differences you've seen over the year?
Yeah, I think that that's kind of it, is that the machines have gotten to the point that you don't need to. When we started, there wasn't the item never existed. There was no such thing as a 3D printer that was big enough to print an AK inner socket.
Mm-hmm.
Or that was really one of the reasons we had to build our own. Besides the fact that we just couldn't find the right materials, filaments weren't at the stage. So we started, the technology wasn't there. At this stage, the technology is there. And again, you don't want to, unless you really love this stuff and really love to do the research and innovate to such a level, you got to sort of pick your battle. You have companies now that have designed these printers. They work well. There's customer support. You don't need to fiddle with, and there's so much out there on the web, right? You Google anything. How do I change a hot end on this? How do I change nozzles? What if I want to? So there's so much information on how to work with these printers or similar printers. You don't really, need to tinker in that arena. But like you had said, what you do is where is the strength now is in the digital design, because that's where now you're taking these materials, understanding their properties, and designing them to their full potential. And I think that's really what we've come full circle with.
Mm-hmm.
Where, while I was in the middle of this, I always used to say, we were really focusing on the CAM, right, of the CAD CAM, the manufacturing, but where is the CAD?
Mm-hmm.
Where is the CAD? And the CAD really does come before the CAM. And you got to say to yourself, where do I want to be? Do I want to be the CAD or the CAM side? Well, the CAM, if you don't necessarily need to be right now, if you're a prosthetist or an orthotist, and you need to design them and let the machines do the work for you.
That's fantastic. What would you recommend to someone who's looking to get into the 3D printing space? What are the first things that they should try and do in your eyes now that we've done this circuit for them?
You need to get a scanner, right? So you have a choice. We use 2 scanners here. We've used every scanner. And I guess the best scanner is the one that works best for you and that you're the most comfortable with. You could get, right, everybody gets the comb scanners. We use the comb scanner here. We use a 9 scan.
Mm-hmm.
So whatever you feel comfortable, you want to lower, if you want to just get in it, get a comb scan. You have your iPhone already. Just download the app. They're not that expensive. I think it's $250, I recall, every few months. So your minimal outlay there. Sign up for your course, right? You start with the
Academy
Fusion and the ZBrush, and then if you want to take it to the next level, buy a Sidewinder and a spool of TPU, and I think you're good for under $1,000, right, or something like that.
Yeah,
you get all the hardware you need plus whatever software. It's a minimal outlay. It's a minimal outlay.
And the only thing you're investing in at that point is your skill set. You're not investing in large machines or anyone else's company model or a SaaS scheme. It's yours, right? You get to walk away with it.
Right.
I'm hoping Mark is printing like his own toys and some of his own stuff on his spare time. I'm sure he's trying.
Of course, he's making figurines for my kids, Mickey Mouse figurines. Are you joking? I brought them home the other day. But yeah, we have a lot of extra TPU, so that's what he does with the extra, and he prints tooling, like I was saying before, and other really cool things. He's really grown a lot.
I think, like, from my experience, and maybe you might agree with me, that like in the more successful models for implementing 3D workflows, it's a dedicated role from someone with a very good mind for some sort of digital layout. So a digital technician who's the between your plaster techs and your clinicians or practitioners, right? And doing that in between.
But look at Mark. Mark is a great example, right? Mark wasn't really a digital anything, right? He was a hands-on guy. He was a motorcycle guy before, and he learned. But he saw enough of what we did. He saw a little bit of from medical, like he knew what we were doing. He saw the whole process, and he watched the other engineers. So he sort of had that
good
background.
Yeah.
But you got to say to yourself, who's the guy who's doing this, and your average audience is going to be the clinician,
mm-hmm.
at least in the beginning.
Yeah.
Because they're not going to trust the technician to modify. I would never let anybody modify my own cast, especially my prosthetics. If I scan something, I'm modifying it. Now, I'm not doing the rest, right?
Mm-hmm.
But I'm doing the medical portion, right? Mark does the fusion, good. But he's just building based off the instructions I've given him. And he can't F that up.
Yeah.
So most people, I shouldn't say nobody, but most people aren't going to give their technicians that much liberty, right? So you really are talking to those clinicians. You're talking to the mom and pop, the 1 and 2 company places, and you got to sell them because they have so many other responsibilities. You got to give them an easy win.
Yeah, right. Yeah.
So you got to, like, again, I'm talking for myself. Like, I am your poster child for this, because the first thing I never wanted to do, and I wouldn't go into this, but I didn't want to spend money on something that I didn't know worked, right?
Yeah.
So I didn't want to spend $30,000 on a scanner, right back in the day, $50,000 on a Polhemus scanner if I didn't know I could use it, right? It wasn't even if I had, if it was worth it, you get a business loan or something. So I was looking at low end scanners. I was dealing with the structure scanners in the beginning,
Mm-hmm.
and they weren't so great. They were a pain in the butt to use, but we used them a lot. Um, at one point, I was leasing what's their Borum scanner, Spectra. That was a pain in the ass to use. Very hard. We were only scanning things, but so my outlay, even on the 3D printers, one of the reasons I don't want to spend $2,000, $5,000 is why am I going to spend $5,000 on something? Again, it was a lot of money, especially in those days, on something that I know is not necessarily going to work. So my printers cost me to make $1,000, $800. You know what I'm saying? Like my outlay. Hey, we built our first carver. It cost me carvers. Now I bought a carver for Medico. It was $50,000. And you know what? I didn't even bat an eyelash. They were a rich guy. No, because the first carver I ever built cost me $3,000. It proved to me that carving works. I've been carving for the last 9 years. It finally petered out. We lost, our engineer. So I'm like, for $50,000, that's a salary for an engineer to run this thing, right? Because they stand behind their work, and it purrs like a kitten. And I know the technology works.
Yeah.
So any new guy, even if they have one, they're not going to spend on an abstract. I remember Willowwood told me years ago that they bought an SLS printer. You're talking probably in 2015 or something like that. I don't know how I even got into it with them. They were experimenting with SLS sockets, and they probably spent like $300,000 on an SLS printer. And they said, yeah, it just sits in the corner. We tried it and it didn't work. But they're Willowwood. They make, $20 million a year. You know what I'm saying? Like,
Yeah.
not the average, mom and pop shop that's going to spend that money. So even the 1,000, 2,000, it all has to, A, you're not going to spend that a lot because there's no guarantee it's going to work for you. But B, you want to win. You need an early win, right? So first, you got to get good at comb scanning, or else you're going to throw the stupid scanner away. But comb is better than the structure because it's easier to scan with. Then you got to teach them how to modify quickly, because at least they'll say, okay, I scanned something and I modified something. Now I could even send it out, right? Step one, I don't want to do the rest. I could still, so I have a win right now. I have a way that I could scan a patient, I can modify on screen, and I can send it to a third party, and I can get a check socket, I could get an inner, I could get a model, I could get a carve, I can get whatever I want. Now you've given me that tool, right? And then you could say, okay, now you want to take this to the next level and make your own sockets and really brand yourself. You know how to do this. Now I'm going to take you home, right? That's how it is, because every O&P owner I know is just tight-fisted with the money. They're worried about everything else, and again, if it works right now, I could slap plaster and I see my patients and I do my deliveries every week, and I don't have time, and I have other employees and I have payroll. I'm not going to sit there and break my brain. But if you show them the first win, they'll say, you know what, I'm going to carve out my weekend now to learn this fusion crap. So you have what to sell. You really do. But you would get everybody. You put in that namaste component, you have your soups and nuts done.
Straight up. All right. Well, good to know. And I really appreciate your input as well. Always, Mike, you guys have really made my work possible. And I'm hoping to share all of our work with the world. And it's all thanks to you guys. And I couldn't appreciate it more.
Good. I was going to say one thing, and I completely forgot right now. But whatever. No, it's good. Just keep at it. Do your thing. Don't oversell, right? Just make sure that you tell everybody that this is still in beta testing, and you don't, whatever. And this is all anecdotal. You can show them the videos but everything is anecdotal. MJF is anecdotal right now.
Yeah.
At the same time, at the end of the day, you're fabricating at your own risk, but you're doing the same thing when you're laminating a socket, and you pray that it doesn't break on somebody. So, you'll do fine. You're finding your way. You're finding your niche, and I think you got that niche right now. You just gotta
finesse and polish the products.
Finesse, polish it, but I think you got it.
Yeah. All right. Well, I really appreciate it. This has been so much fun. All right, guys. That was a wrap for the episode that we wanted to disclose with you guys. Mike, are you with me here?
Yes.
Awesome. I can hear you. I hope you all can hear me. It's yeah, it was really fun doing that recording. We did that a little while ago, and ever since then, I think some things have updated. This was in response as well. Disclosing this episode from the course that I'm going to be releasing soon. There was a lot of interest. There was a lot of feedback around people's experiences with MJF and experiences in FDM. I know, Mike, you've had some developments too, just on your end. Is there anything that you'd want to add at the end of the video now that some of the time has passed and we've had a chance to see it again?
The most important thing I want to add is that I do change my shirt. For some reason, I'm wearing a blue shirt in the video, and I'm wearing a blue shirt now. I happen to like blue shirts. This is a new blue shirt.
I mean, if that's the most important thing, I guess, yeah.
Yes, that's the most important thing. I think the important thing is just to you have to start. Everybody has to dig in. It's very promising, what one can accomplish. We are very excited for what we've been able to accomplish in the last year. Last year alone has been exponential compared to the years before, and you got to learn to be the digital designer. You definitely do. So talk to Art, and I'm a big fan, and
Yeah, that's awesome.
let him teach you his stuff.
We'll be doing some more interviews, or at least I'll try to release some more interviews. Mark Rico, the lead technician we were talking about, he did a lot of legwork, as well as Brittany Mohan, a resident and eligible prosthetist at this point, if I'm correct. And they'll be sharing their experiences through the training as well. But really exciting stuff. Just again, having the opportunity to see FDM and MJF's neck and neck, and being able to perform. Some of the questions that came from the webinar, I'll read them to you, Mike, just because I don't think you can see them. We had a question about the latticing. So the logic behind the distal end pattern for strength. That was for corrugation, but it is also a design feature that you can control the stiffness of the material. You experimented, Mike, a bit with having that type of lattice just on the distal end, and essentially hardening up the distal end, which is just another feature that you can use to control that. And then variable wall thickness being another one. So reducing the wall thickness leading up to the proximal trim line, and being able to have that malleability. What was your experience, Mike, having that as a feature? Like, did you find that it was like it really made the difference, or it was more of an aesthetic treatment afterwards?
No, I mean, again, a side benefit is the aesthetics, which a lot of people, again, just in my clinic, happen to really like the way they look. But it's 100% function. It's mechanical in terms of the strength it provides, and again, that's going to be everyone who's going to be tinkering with this has to sort of play with. There's a balance with everything. You want strength. You want not to, you want to manage the weight of these devices. Some areas perhaps you want a little bit more flexibility, and that's where the balance of wall thickness and lattice, and how much lattice, and how tight or how loose, all plays in, and that's what's exciting. This is beyond regular design. This is really next level.
Yeah.
It's not even just structural strength now. It could even be clinical applications to how you're designing your sockets.
Yeah, exactly. Brody, we did create those lattice structures inside of Fusion 360. There are several templates that my course will eventually teach you. There is the one shown on screen. There's also a spring-based lattice and a knurling-based lattice, which allows you to have variable walls throughout your lattice. So at the base of the lattice cavity, it gets really wide, and then you can have it thin out. So there's 3 different types, and they're all native to Fusion 360, so fully parametric, fully updatable, which is, again, really exciting. You're going to be able to dial in your design to suit your needs, just like Mike did, and how you use it is up to you. We had a question probably for you, Mike. The TPU, what TPU do you find works best for this TPU socket? And, what shore density are you using for TPU?
So it's a good question. We've used lots of different companies. I would say a shore density of 95A, at least, is appropriate. But I find that depending on the company, some 95s are stiffer and some are more flexible. You just sort of have to, and some print shinier, some print more matte. everything, is just a trial, and that's what's fun about it. Also, you just open a box, you try it. The investment's not that much, but those are some good parameters, in general. But TPU at the end of the day is, it's not like every TPU is the same, but they're within a certain family, so the printing ability and the results, they're not going to vary crazy. You may just see some, minute or smaller results, at least in my opinion. But we've used at least 5 or 6 different brands.
Nice.
So, yeah.
Gotcha. I think, can I show this? Hey, there we go. I can actually show the comments. Dennis asks again, what MJF material did you use for the failed sockets, and were they vapor smooth? We used PA12 for our sockets, and I can't recall, were those
They
vapor
were.
smooth?
We did
They
both.
were.
We did both. Vapor smooth, not vapor smooth.
Did you see a difference between the two?
No.
Yeah.
They were strong until they failed.
Yeah, exactly.
Once they failed, again, I'm not gonna say that I'm the MJF guru. I
No.
had a limited exposure to it, and maybe somebody out there knows a way to manipulate it. It's just whenever we would break these sockets, we would get this shattering effect. And to me, I would have felt more comfortable if it was more localized. But maybe again, I'm not saying that, maybe out there that, you do get more localized. Just that was our experience. These shattering sockets, which I don't really see in any other OMP applications. Like I said, maybe a PolyPro device. But that was my experience. And like I said, maybe there's somebody out there has a better technique or a better company or a different PA12. But yeah, that's all I can tell you on our end.
Yeah. Yeah, and we're not trying to bash at MJF PA12 or PA11 at any stretch with this kind of proposals. There's lots being discovered and explored, and there's lots of successful deployments of PA12 as an end-use product in the field. Just highlighting the fact that good design really is key, and good design can not only carry or break a successful product in PA12, but it can actually carry or make something that's considered much less inferior to really go a lot longer in distance compared to what people might expect.
Yeah, like we were talking the other day, and then I guess you have another question. We found our answer in TPU, but who knows? Maybe somebody else out there, and that's one of the reasons we're sort of. I'm happy to share, some of this is that, maybe somebody else could figure this out with PolyPro. Maybe someone else, maybe PET-G. I know people are walking, a lot of people on these really crazy check sockets, but maybe, with proper design, PET-G won't break, and maybe that's the answer for everything. Maybe MJF, somebody could figure out a different design that it won't shatter. I don't know. I was once thinking of a honeycomb pattern that it would
Oh yeah.
localize break. I don't know, but that's the beauty. Everybody, you get this basic knowledge, and then you go at it. Maybe PLA, there's PLA plus. Who knows, right? There's wood, but maybe with all these tools, and a community out there who's going to tinker and learn and experiment like we did. We're just one clinic. Maybe we'll come up with many materials with different benefits.
Yeah.
That would be great.
Yeah, and that's the goal of OMP Digital Designer. It really is sort of like a crowdsource, like open knowledge, being able to share our findings as we go, and not providing the answers, but providing the method for you to be empowered enough to do these kinds of developments yourself, to build your own product, which is at the end of the day what any prosthetist is sort of that's the ultimate goal, is to represent yourself through product. Josh is asking the average time to sit at a computer to model these sockets with the VIP vacuum. Do you happen to know how long it's taking, Mark?
Yeah.
I know he's improved massively since I've
Great.
started. He keeps
So
reducing his time all the time.
there's the other part we didn't talk about. There's two ends to this. It's the model rectification, right? Which you have your raw scan, and then you want to do your digital plaster work, or you want to add your reliefs and your reductions and model as if for anything else. So that's separate. Just so we're being very clear now, that has nothing to do with the clinical modeling. We happen to use a company called Medico. They're a great company. I also have no financial ties with them. There's cheaper versions. There's easier versions. We mentioned Namaste, which I think is a free version. So either way, you have to do that, and that's that's however long that takes. To me, it's equivalent to working with plaster. Then there's the socket construction, which is really the fusion work and the ZBrush work. That's building your digital walls of your socket, which is all the lattice and everything we're discussing now, right? Just so in case we were unclear before, there really is two parts to this. When Mark started, it probably took him an hour, you know. Now he does them. He knocks them off in 20 minutes, right?
Nice.
So think about it, 20 minutes, and he's great. 20 minutes, you set it to print, you come back the next day, and you're done. How many items, and then you're just assembling for the most part. A little extra post processing work, very minimal, and you're assembling. I mean, it's you can't
can't
bring
go
that
wrong.
to anything else.
Yeah.
Right now, no, Pete, to my knowledge.
Yeah, and the concept is well known. Like I used to work in sales for 3D printing, and yeah, the lights out printing is a nice a thing that you can sell printers with. Is like for the first time ever, you can cash in on your overnight hours as a company, provided you put the upfront in and set the printer on before you leaving. At the end of the day, so 20 minutes of modifying, come back the next day, and you're doing an hour's assembly. You're coming out with a net gain, especially again using a $400 printer and $20-30 in TPU.
Yep.
It really is a no-brainer. So I don't see any other questions on the docket. We are at about time for the episode. Really big thanks to Mike Nadata and NY Rehab for all of your work doing the testing and going through my training, vetting some of the decisions I was making, and helping me refine what will eventually be a full-on course. So thank you again, Mike, for everything you've done. It's been amazing.
My pleasure. Thank you, Art.
Nice. And just to add to the end, I think, can I do this? Can I add this to stage? Yeah. So there is a new announcement. Coming October 23rd next week, we're going to be releasing the course that NY Rehab went through to do this kind of work. This workflow does have concepts and does explore different designs that are suitable for MJF and FDM printed workflows for various materials. How you use it and how you decide to move forward with it is up to you. But again, these workflows are going to help you confidently experiment and play with a setup that's affordable and available to most people, as a desktop printer to get started. There's also going to be a prosthetist bundle, so you can get 3 of these courses, especially if you're a beginner. If you want to start this and you're looking to get into it for the first time, but you don't think that's, it's too advanced, there is a prosthetist route for, beginners, where you can sort of flow through, 15 hours of video to become proficient to get to that level. It's all available on the ONP Digital Designer Academy store, and we'll be releasing that to you guys next week. So really excited to share that with you all. And otherwise, it's been a lot of fun. And again, I thank you, Mike, for showing and sharing the knowledge. And I'm sure we'll be back talking more about this next time.
My pleasure. Have a good night.
Awesome. All right. Thanks, guys. We'll talk soon.